Problems involving vector operations example. The diagram below shows a river with two parallel banks. The river is 300 meters wide. So this is 300 meters. A is a point on one bank and B is a point directly opposite on the other bank. Jasper is at A. He can row at 2 meters per second in still water. He sets a course directly towards B, and we can see that the current is flowing this way at 0.8 meters per second. How far downstream of B does he land? So Jasper can row at 2 meters per second, and he sets course directly towards B. But of course the current is going to drag him off course. So he'll end up heading in this sort of direction. Now we can do this using similar triangles, or we can actually find angles and so on. So let's use a similar triangle. So for every 2 in this direction, he'll go 0.8 this way. So to cross, he's going 300 in this direction. And of course the scale factor here is 150. So that's going to be 150 times 0.8 in this direction. So let's just calculate that. So 150 multiplied by 0.8 gives me 120. So how far downstream does he land? 120 meters. Now I've left all the working from the previous part here. How long does it take him to cross? Well, he's doing this every single second. So every 1 second he does 2 across and 0.8 this way. And we know from the similar triangles that he just have to do that 150 times. So it's going to take him 150 seconds, or if you like, 2 minutes and 30 seconds. If Jasper wants to land at B, in what direction should he head and how long will it take him to cross? So he now wants to head in a direction, so he's going directly across from A to B. And that means he needs to steer in this sort of direction, and then the current will bring him back. So it'd be handy to know this angle, and of course we're right angled just here, so that's the opposite and the hypotenuse. So the sine of theta would be 0.8 divided by 2. So theta is going to be the inverse sine of 0.8 divided by 2. So if we bring in the calculator, so we want the inverse sine of 0.8 divided by 2, and that gives me 23.6 degrees, we'll say. So we'll say 23.6 degrees to the direction AB, aiming upstream, to distinguish it from aiming in this direction, which is downstream. Now, let's consider the actual speed that he manages in the direction AB. So that's just the third side of this triangle. We can use Pythagoras. So let's call it V, and it's going to be the square root of 2 squared take away 0.8 squared. So we can calculate that. So we've got the square root of 4 take away 0.8 squared. So we might as well stick with that exact answer. No, let's just put it down as a decimal. So it's 1.83. And we know that he's got to do 300 meters. So it's going to be 300 divided by the 1.83, except I'll use the whole of the last answer. So we have 300. We're dividing by my last answer. And so that's 163.7 seconds.